Well, hello, everybody, and welcome to Election Day 2022. It's an asynchronous day, so we're going to get this stuff done remotely today. We're going to do a little bit of work with Boyle's law that we introduced last time. Remember, it's this relationship between pressure and volume. They're inversely proportional, meaning if we increase the pressure on a gas, its volume will actually decrease, and vice versa. And we're going to do a few word problems here. We're going to apply our Boyle's law formula up here. And all you have to do today is follow along, complete these problems with me, and submit your work for full credit on this asynchronous election day. So let's get right down to it. Normally in class, we would have done a little group practice, and then I would have set you free. We're going to look at various scenarios here. It says, do the math for each word problem. Imagine the gas is contained in a balloon and draw what the balloon would look like before and after each treatment. Show your work. We want to be able to figure out where we went wrong if that's the case. So here we go. The first problem says a gas occupies 12.3 liters at a pressure of 1 atmosphere. What is the volume of the gas when the pressure is increased to 1.3 atmospheres? So first things first, let's identify the variables we know and the variables we don't know. Initial pressure, initial volume, final volume. Do we know the initial pressure? The initial pressure is 1 atmosphere. Yes, we know it. Do we know the initial volume? Yes, it is 12.3 liters. They're asking us what is the final volume of a gas when the pressure is increased to 1.3 atmospheres. Okay, so our final pressure is 1.3 atmospheres. We're going to use our units here. All right, so let's set this up. We know that 1 atmosphere times 12.3 liters is equal to 1.3 atmospheres times, who knows, we're going to solve for V2. To get V2 alone in this equation, we're going to divide both sides by 1.3 atmospheres. And in this case, atmospheres will cancel out, and we should have our final answer here. Let's see if we can solve for this thing. We'll go split screen calculator here, and we'll go, 1 atmosphere times 12.3 liters. We know that's going to be just 12.3. So 12.3 divided by 1.3 is going to give us 9.46. We'll round that to 9.5. Now we got to figure out what unit we're in. It's volume, so it must be liters, and we can actually tell it's liters because we have atmospheres on top and bottom, and they'll cancel each other out there in our math. So volume 2 is 9.5 liters, and that would make sense, right? If we have a balloon, if we have a nice red balloon at 1 atmosphere and we squeeze that balloon, we would expect it to shrink a little bit. We would expect its volume to decrease if the pressure goes up. Now, here's what I'd like you to do. If you could, I think it would be best if you maybe pause the video here and go ahead and see if you can complete these problems on your own, and then maybe go back and watch me complete them to check your answers. Be sure to turn in your work when you're done. But I would suggest pausing now and then completing your work. So I'll give you a chance to do that. Okay, and we're back. Hopefully you got all that work done. And now you're following along with me to check your answers and make sure you did these problems correctly. So again, let's identify all the variables that we are given. I guess V1, P1, V2, P2. We'll figure out in this word problem what we know and what we don't. So a gas occupies 1.5 liters. That's its initial volume, 1.5 liters. At 1 atmosphere, okay, 1.0 atmosphere, that's the initial pressure. What is the new volume if the pressure becomes 3 atmospheres? Okay, 3 atmospheres is our final pressure. We want to know our final volume. Okay, the math is similar to our group problem up there above. Let's see. Let's go P1 times V1, 1.0 atmospheres, times 1.5 liters is equal to 3 atmospheres times V2. We got to get V2 alone, so I'm going to divide both sides by 3 atmospheres. And take this, divide it by 3 atmospheres. Boom, those cancel out. 1.0 times 1.5 is going to be 1.5. 1.5 divided by 3 is going to be 0.5. V2 is equal to 0.5. What's my unit now? Well, atmospheres cancel out. I know I'm solving for volume over here, so it's got to be 0.5 liters. We're going to take a 1.5 liter balloon. We're going to triple the pressure on it, and we're going to shrink it down to a third of its size. That makes sense. It's all proportional. All right, so our next one, it says, all right, so P1, V1, V1, P2, V2. We'll see what we're solving for here. A gas occupies 6 liters. Okay, that's the initial volume at 4 atmospheres. Okay. And what would be the new volume? All right, we're solving for volume again if the pressure were decreased to 1 atmosphere. All right. So we're going to decrease the pressure. That tells me, all right, so here's my balloon I'm starting with. If I decrease the pressure, my volume should go up. Let's see if that's the case. Let's take 4.0 atmospheres times 6.0 liters. That should be equal to 1.0 atmospheres times V2. We're solving for V2. We got to get that alone. So I'm going to divide both sides by 1 atmosphere. That cancels out over there, 1.0 atmospheres. So we're going to go 4 atmospheres times 6 liters. That's 24 now, divided by 1. We know the answer there. That's going to be 24. Our final volume is equal to 24 liters, right? Because, again, atmospheres cancel out. We're solving for volume. It's got to be 24 liters. And that makes sense, right? We started out with 6 liters. Now we have a quarter of the pressure, so we have 4 times the volume. They're inversely proportional to each other. All right, last one. Let's get our variables identified. P1, V1, P2, V2. Here we go. Let's see. A gas occupies 2.0 liters. All right, that's the initial volume, 2 liters. At 1 atmosphere. All right, that's our initial pressure. What is the new volume? Okay, we're solving for volume again. P2, what's our new volume if the pressure were to become 4 atmospheres? All right, let's see if we're starting to get the hang of this. If I go from 1 atmosphere to 4 atmospheres, I'm quadrupling the pressure. If I quadruple the pressure, this law tells me that my volume should be 1/4 of the volume. We should be down to 1/4 of our original volume. Let's see if that's the case. All right, so the initial pressure is 1 atmosphere times 2 liters. That's equal to 4 atmospheres times, we don't know, V2. We're solving for that. Let's divide both sides by 4 atmospheres to get V2 alone. All right, 1 times 2 is 2. Right, 1 atmosphere times 2 liters is 2. Divided by 4. Atmospheres, that comes out to 0.5. So V2 is equal to 0.5 what? Well, atmospheres cancel out. We're left in just liters. We also know it's liters because we're solving for volume in this case. And sure enough, we quadrupled the pressure, and now we have 1/4 of the original volume. It all works out. So hopefully you've got your answers in here. You've been following along. Hopefully you did it on your own, and you're just confirming that, yes, you got all the correct answers, and you are good to go. Be sure to submit this and get full credit for this asynchronous election day. And I will catch up with you guys next time. Thanks a bunch for tuning in. And if you like today's video, be sure to like and subscribe and hit that thumbs up button. You guys have no idea how much that helps. Really gets my views up and gets my subscriptions up and helps me go viral. So I really appreciate it. And I'll see you guys next time.